Hello and welcome to Algebra 2, 7.3, and these are your extra examples. So if you need a few, pay attention. All right, so first of all, composition of functions. So when you have a function of a function, so we're going to start out with f of f. So in this case, you are composing the same function. So f of, remember you always replace this one first, so 2x to the negative first, and then I'm actually going to evaluate f, and every time I see an x, I'm going to put in a 2x to the negative first. So this becomes 2 times 2x to the negative first, which ironically is 2 times 2 to the negative first, x to the first. And so this 2 goes down, and we get 2 over 2 with the x on top, and we end up with just x. Okay, so now we have to look at the domain. And this is where, in the original lesson, we were mostly looking at the final answer. And so if you look at this final answer of x, you're like, well, that can be all real numbers because they would all be defined. But this is where you have to go back to, you always have to look at this domain first. So if I come back to f of x, what is this domain? What's the domain of 2x to the negative first? Well, it's all reals except 0, because that really is 2 over x, and x cannot be 0. So you start out with a domain of all reals except 0. So when you get to the end here, you have to at least keep that original domain, but you might also be adding to it. In this case, we're not. So even though x should have a domain of everything, this domain is all reals except 0. And so that's where that looking at your domains first comes in handy. So let's try this out with some different functions. All the examples we've done so far have been the same functions. So to start out with, what's the domain of f? That is all reals except 0. All reals except 0. And the domain of g, that domain is all reals. So if we're looking at, in this case, f of g of x, this domain of g is the one that counts first. So I'm going to start out with the domain of all reals. Okay, so we're going to do f of x plus 1, because that's what g is. And then I'm going to evaluate f, so I'm going to have x plus 1 to the negative 1, which is 1 over x plus 1. So there's my answer to my composition, and then question becomes, well, what is its domain? And I started out with the domain of all reals, but now, because I have an x on the bottom, that x cannot be negative 1. So we are adding to our domain all reals except negative 1. So let's do the same functions, but this time we're doing g of f of x. So if we remember just from a minute ago that this domain is all reals except 0, this domain is all reals, so you are starting out with this domain, this one right here. So we are starting with a domain of all reals except 0, so we have to at least end with that. So this is going to be g of x plus 1. Actually, nope, did that backwards. Let's try that one more time. This is going to be g of x to the negative 1, which is going to be x to the negative 1 plus 1. And we're going to send that x to the bottom and get 1 over x plus 1. So now, when we go to do the domain, we started with the domain of all reals except 0. And if we look at this, that's the same domain that we're going to keep here. Because again, with that x on the bottom, it still can't be a 0, so we're going to do all reals except 0. So one more we're going to look at here, and again we're going to do f of f. And so we are starting out with the domain of all reals except 0. So we're going to do f of x to the negative 1, which is going to look like x to the negative 1 to the negative 1, which is x to the positive 1, which should look like its domain is all reals, except we started with the domain of all reals except 0, and we have to keep that domain. So when you're doing a composition, you start with the domain of the inside function, and then you're going to look at your answer and possibly add to it, but you can never take away from it. All right, so 2 word problems to end with. You do an experiment on bacteria and find that the growth rate g of the bacteria can be modeled by g of t equals 82 t to the 0.25, and that the death rate d is d of t equals 10.8 t to the 0.25, where t is the time in hours. Find an expression for the number n of bacteria living at time t. So to find how many bacteria are living, we're going to have to take the growth rate and subtract the death rate, and that should be how many that's left. So very nicely, this is 82t to the 0.25 minus 10.8 t to the 0.25, and you could call this n of t. And so because they're both t to the 0.25, we're going to do 82 minus 10.8 and get 71.2 t to the 0.25. And that would be how we would find our number of living bacteria. Okay, a computer catalog offers computers at a savings of 15% off the retail price. At the end of the month, it offers an additional 10% off its own price. Use composition of function to find, don't know where I got the word model from, to find the total percent discount. Okay, so if the first thing they're going to do is they're going to take this 15% off. So we're going to end up paying, actually if we want total percent discount, all right. So if we are going to, if we're going to get 15% off, let's actually do it, then we're going to pay 85%. So we're going to pay for 85% of the cost of our computer. So then the composition function, so that would be our inside function. So our composition function is going to say, well, if we take an additional 90% off, then we're going to take an additional 10% off. We're going to have to pay 90%. Okay, so 15% off means I'm paying 85%. 10% off means I'm paying 90%. And so what you're going to do is just going to multiply those. And we're going to get 0.765x. So if I am paying 76.5%, I am going to be saving 23.5%. So that is going to be my discount because we did it based off how much we were going to pay. All right. And hopefully you can read that okay. Okay, so what would be the sale price of an $899 computer? So what you just need to do is take your 0.765, which is the percent we're going to pay, times $899, and the sale price, rounded to 2 decimals, because that's how money works, $687.74. All right. There's your extra examples. Email me if you need to. Let me know if you have any questions, and we'll see you in class.